Hello everyone, my name is Assistant Professor Khole SV, Department of Electronics, AM College Pune. Today we will see about Embedded System Design, Chapter 2, Architecture and Overview of ARM1176JZFS. This is the Raspberry Pi 3 Model B. It contains processor which is of CPU Broadcom 2835. It also has a GPU and also has a memory. This is system on chip. It has 40 pin GPIO header. Then on this side you can see it has a DSI micro port which is used to connect a touchscreen display. Then behind this, on the back side, it has a small micro SD card. You can insert an SD card. In this SD card we can install the Raspbian OS, which is Debian OS. On this side we have micro USB, which is the power for this whole Raspberry Pi Model 3. This one is HDMI to connect an external monitor using HDMI port. Here we have CSI camera port to connect an Pi camera to the Raspberry Pi directly. We have an Ethernet port, so here we can connect an RJ45 Ethernet cable. Then here we also have two USB ports. These two USB ports each have separate two slots, so total 4 USB ports, each of 2.0 version. This Raspberry Pi 3 Model B also has an Bluetooth of 4.1 and Wi-Fi enabled facilities. Next slide we see about the processor overview. In processor overview, this is a processor which is coming from the ARM11 family. This ARM11 family is of 32-bit processor, and in this left hand side diagram here you can see the ARM1176JZFS processor. This processor consists of debug interface block. It also has an vector floating point optional facility. It has a coprocessor controller. On the center here we have the trust zone enabled ARM11 core, which is the processor. It is powered by the ARM controller. Then it has two types of caches. One is instruction cache and another is data cache. Each cache has tightly coupled RAMs, which is called as TCRAM0 and TCRAM1. Below this block we have memory management unit, and below memory management unit we have AMBA AXI interface, which is called as Advanced Microprocessor Bus Architecture. This is the bus architecture which was invented by the advanced RISC machine manufacturers. It consists of 4 types, which is instruction interface, data interface, DMA interface and peripheral ports. These 4 blocks consist of a total AMBA interface bus. Now coming to the processor name, our processor name is ARM1176JZFS. Now JZFS means, here you can see on right hand side, J is called as, it supports the Java bytecode execution facility, which is also called as Jazzel support, and Z means the trust zone software security. This trust zone software security is to secure your total ARM processor from the other vulnerability conditions. Then F means it has supporting the hardware floating point software, and S is called as synthesizable conditions. Next we see the features. These features consist of designed for consumers and wireless products. RISC is called as the reduced instruction set of computing processor with Harvard architecture. This ARM processor also consists of vector floating point coprocessor. It has branch prediction facilities. Then it has trust zone security built into the CPU. It has 2 types of caches, which is called as instruction and data cache. It has 8 stage of pipelines, 32-bit and 16-bit instruction supporting facilities. 32-bit is the total words, half word size facility. 16-bit is called as the thumb facility for instruction set, which is condition of the Jazzel technology for executing Java codes. Here you can see processor operating stages, which are as follows. It has 3 types of processor operating stages. First is ARM state, which is called as 32-bit. This 32-bit ARM state is of word aligned ARM instructions. Second is about the thumb state. Thumb state is called as 16-bit. This 16-bit thumb state is also called as the half word aligned ARM instructions. And third one is called as the Jazzel state. Jazzel state is actually a variable length byte aligned ARM instruction. So in this Jazzel state you can give a variable size to different types of instructions. So it automatically takes the variable length size and automatically aligns into the respected ARM instructions. On the next slide we can see about the pipeline stages. Now this ARM1176 JZF processor has 8 pipeline stages. Basically, if you see, the previous processors used to have 3 pipeline stages, which was consisting of fetch, executing and decoding. Now these ARM11 processors have 8 pipeline stages. In this block diagram you can see these 8 pipeline stages are divided into different categories. First one is called as FE1, which is called as the first fetching stage. Second is the FE2, which is called second fetching stage. Third stage is called as the instruction decode, which is called as DE stage. Fourth is called as the register read and instruction issue stage, where it is called as ISS stage. Next one is called as the shifter stage, which is called as SH. Next is ALU operation stage, here which performs the different types of ALU operations. Seventh one is called as the saturation stage, and last one is called as the write back stage, which is the write back from the MUL or ALU stage. So this is the common 8 pipeline stage whenever the processor follows, and is shown by the red arrows starting from the FE1 to WBAX execution stage. Now this image has been taken by the image reference from the ARM1176 technical reference manual. So the arrow shows you the typical ALU operations when the processor executes. The processor executes actually these 8 stages of cycle in one cycle. So actually if you see that processor takes completely one cycle to execute one ALU operation. So this is a simple calculation. So whenever the processor is performing one ALU operation, it takes one machine cycle. Next figure shows you about the typical ALU operations execution by the ARM processor. Now first 4 stages of the pipeline are called as the common decode pipeline, which is called as FE1, FE2, instruction decode and register read and instruction issue. Then 5th stage is called as the shifter operation stage, which is shown by the arrow. Next is called as the calculation for write back value, which is called as EX2, or it is also called as ALU operation stage. And 7th one is called as the saturation stage. So these 3 stages, shifter operation stage, then calculating about the write back value from the ALU operation, and saturation stage, these 3 stages come under the execution stage. So this is execution 1, execution 2 and execution 3 stage. And last block is called as the write back execution, which is called as the base register write back. So whatever ALU operation gets the final result, this final result from the write back register is stored into the particular memory. So this is the flow of the typical ALU operation execution, which is done by the ARM1176 processor. Now one condition is that whenever the ARM processor is using ALU operation pipeline stage, the processor is not able to use load and store pipeline or MAC pipeline. So only one pipeline stage is used by the ARM processor whenever it is performing ALU operations. In next figure you can see the typical operations for multiply and accumulation. Now again in this same diagram we have 4 common stages, which is called as common decode pipeline. So FE1, FE2, decode instruction and register read and instruction issue, these are the 4 common stages. Next stage if you see during the multiply and accumulation is the MAC1, MAC2 and MAC3, and after the final result which is there, when the instruction goes from these 3 loops, the final result is obviously seen in the base register write backs over here. So here we have to always remember that whenever the multiply instruction is executed by the processor, it always undergoes through these 3 loops, MAC1, MAC2 and MAC3, and until it produces the final result is observed in the WBX register. Next figure shows you about the load store operation. In this load store operation, little bit we have 2 different conditions. Again over here in this diagram you can see common decode pipeline, which have 4 stages, FE1, FE2, instruction decode and register read and instruction issue. Then during the load store operation, your processor goes towards the data address calculation, which is shown by this down arrow. After data address calculation, there is first stage of data cache and second stage of data cache, which is accessed by the processor, and last the whatever final result is done, whether it is load or store operation, that is done at this WBIS register block, which is called as write back from the load store unit pipeline. So in this main condition is what, whenever the processor is performing any load store types of operation, the processor can simultaneously use the ALU operation pipeline also. So in this condition, two operations can be done simultaneously, that is load store operation or ALU operations. So this is the main thing which you have to remember. All these images have been taken by the ARM 1176 technical reference manual. I hope you must have understood about this common decode stages of pipeline in the ARM 1176 JZFS processor. So it has 8 stages of pipeline. Thank you so much.